So, hello everyone. I think let's continue solving this exercise. So we have solved the number 3, number 7. So let's quickly move on with number 11 and 16. In fact, the number 11 and 16 are somewhat a big number. They are somewhat big numbers. So we are going to solve it the same way we have solved the first two. And it is using the factor method. So firstly, we draw the line and we put the numbers there, 288. So as we have done for the first one, we ask ourselves, so we can use 2. It is 2 we use because 2 is a factor of 288. And then it is also a prime number. So we use 2. So that is why 2 is what? A prime factor there of this number. So 2 into 1, 2 in 8, 4, 2 in 8, 4. We can still use 2. 2 is still a prime factor. So 2 in 14, 7. 2 in 4, 2. We can still use 2. 2 in 7, let's do one by one. 2 in 7 is 3. You keep 1. In 12, 6. We can still use 2. 2 in 36, 18. Then 2 in 18, 9. Can we still use 2? No, 2 is no longer a factor of 9. It's not a factor of 9. So we use what? 3 rather. 3 in 9, 3. Then 3 in 3, 1. So we write out the numbers. So we have 2 times 2 times 2 times 2. How many 2's? 1, 2, 3, 4, 5. Times 2 times 3 times 3. And that could be written as, better we write it up there. So we have 2 times 2 times 2 times 2 times 3 times 3. So we have 2 to the power of 5 multiplied by 2 to the power of 3 to the power of 2. And here is it. We have expressed this 288 as a product of prime factors. You see that all the numbers there are prime factors. So let's move to the next one, the number 16. Which is a much more big number, 17,325. So how do we get the prime factors of this? Looking at this, definitely we can say 2 is not a prime factor of this big number, 17,325, because the last digit there is 5. The last digit there is 5. So, but why do we say? Because the last digit there is 5. So, and that shows that 5 can be a factor of it. So we use 5. We use 5 instead. We say 5. So 5 in 17. So we have 3, remainder 2. In 23, 5 in 23, we have 4, remainder 3. 5 in 32, we have 6, remainder 2. Then 5 in 25 is 5. We can still use 5 since the last digit of this number, 3,465, is also 5. So we use 5 also. So 5 in 34, that is 6, remainder 4. 5 in 46, that is 9, remainder 1. Then 5 in 15, we have 3. Can we still use 5? The answer is no, we can't use 5. So what other prime factors can we use for prime number? Looking at this, we have some rules of how this number. The reason why we say 5 is a factor of 17,325 is that the last digit of that number is 5. So one of the rules that we showcase to you that 5 is a factor of a big number is for you to look at the last digit of the number. If the last digit is 5 or 0, definitely 5 is divisible by the number, no matter how big the number is. But in this case, 5 has stopped being the last digit. So what other things? How do we identify a number that is a factor of this? When you look at this number very well, there is another root, there is a root of 3. 3 is divisible by this big number, 693,000, because the root of 3 says that the sum of the digits must give us a number that is divisible by 3. So when you add 6, 9 and 3 together, that gives you 18. And 18 is divisible by 3. So also it is sound for us to use 3. Some of you may say we can also use 3 here. Yes, but we choose to, it depends. You can also use 3 from the beginning. 3 can also divide this big number here. But since we are sharing with 5, so let's continue that way. So 3 in 6, 2. 3 in 9, 3. Then 3 in 3, 1. You see that the sum of 2, 3, and 1 also give us a number that is divisible by 3, and that is 6. So meaning that we can still use 3 in it also. 3 in 23, that is 7. Remember 2 in 21, that is what? Also 7. Can we still use 3? The answer is because 7 plus 7 will give us 14, and 14 is not divisible by 3. So what else can we use? It is easy. We can use 7. It is clear. 7, yes, 7 is a factor of 77. So we can use 7, and it's also a what? Prime number. So all these are prime factors. So 7 in 77 will give us 1. Can we still use 7? No. So we use 11. The next. 11 in 11, 1. So we have what we have there. We have 5 times 5 times 3 times 3 times 7 times 11, which can be raised in index form to be 5 to the power of 2 times 3 to the power of 2 times 7 to the power of 1 times 11 to the power of 1. And here is our final answer. We have successfully expressed these numbers as a product of prime factors. Thank you for watching.